Okay, well, we're going back to the future again. This is 2014, new recording of a lecture that did not exist in 2013. So anyway. And I think what we're going to do is we're in the middle of chapter 6, and we're going to start right in with the demo. Okay, so here is our demo. First of all, let's take a look at chapter 6. So we had these count, and then we had univ, and we did that enlarge with the figures, and we did functors, and we looked at third version of count, and then we did the assert and retract. And we did that memoization. Remember the Elmer Fudd thing? And then we did bag of and set of. All right? And now what we're going to do is we're going to see how Prolog, how we can do interactive input-output with Prolog. That's one of the things we'll do today. So check this out. Here we have a predicate called cube, and C is the cube of n. So C is like our output one, and it's a very simple one. It's just C is n times n times n. So let's do gprolog here, and let's consult ch6.pl. And so here's the question. What happens, can you predict this? This should be obvious. This was an easy one. So what if we do cube 2 comma capital C? What will that be? Yep. And if we do the same thing, only we do cube 3 capital C, what will that be? Yep. All right. So now, that's just a simple predicate that does cube. But what if we want to have something a little bit more user-friendly, and we want to be able to have a program that will prompt us, the user, for a value, and then output the cube for us. So here's to see how that would work. Let's start by doing a demo of the write predicate. So watch what happens. If we say write 3 period, what do you suppose happens? Yeah, just 3. Is everybody good? Okay. And then what happens if you say write ABC? What do you suppose happens here? Yeah, why the heck not? And what happens if you say write, now those were not variables, right? What do you suppose happens if we say write X? Where X is, now this is uppercase X, so X is a variable. So what do you think? Check that out.
Is that the space that it takes in, like what is the underscore 279?
Yeah, good question. Have we seen something like that before? An underscored blah, blah, blah?
Yeah, when it goes to match it.
Yeah, that's when it goes to match it. That's like the internal.
So it depends on how the right predicate is defined, or how it's, the thing's defined up there.
Yeah, it's the internal representation of that variable when you do matching. Does everybody see how that works? So that's how write works. But now watch this. What happens if we do, if there's a write, there must be a read. What happens if we do read X? Now this might be a little hard to predict, but watch this. Ha! What's happening? It's waiting for us to get input from the keyboard. Are you with me? So if we do ABC period, what do you suppose is going to happen? Yes, it matches it. Is everybody clear? So do you see how we do input? Input is done with matching by reading a variable, okay? So what happens if we say read and then variable X, comma, and then write variable X? Now this time, when we read, now can you predict what's going to happen here? This time when we do read X, it's going to stop and wait for us to enter something, yeah? So suppose we do A, B, C here. Now when we write x, what? It's been what? Instantiated, okay? So does everybody see how that worked? Okay? And, you know, same thing, if we do this and we do like 34, period, then x matches to 34. Is everybody good? And how about this? How about read x? And when we read x, we do a structure. So how about we do A, parentheses 5, comma, B, C, D? What's going to happen? X matches just as if it were to do a match. Does everybody see? So we input structures the same way. Okay? And how about if we do read x and we have something with a list in it? So suppose we do DEF and then the list 1, 2, 3. So what do you suppose is going to happen here? Yeah, the DEF, yeah, it's a structure, so it includes the whole, it matches the whole structure, just like even the argument, okay? And what happens if we say, read x, and now it waits for input, and we do DEF. Now, what do you suppose happens if we do DEFY? Because it's waiting for us to type something, and then it's going to match the DEFY with X. So what do you suppose this is going to be? Okay, so it matches it, but then that Y is it's an anonymous. It's like it could be an anonymous variable. It's a variable. It hasn't been instantiated. Yeah. Okay. So our conclusion from all of this. Oh, and by the way, every single time we did an input on this, what did we have to end it with? A period, because what it reads is terms. Now, do you guys remember what a term is? Here, let's go to this figure 2.1. Do you remember what? So these data objects are either simple or structures. Simple are either constants or variables. Constants are atoms. What is a term?
Atoms, numbers, variables, and structures.
Yeah, they were the leaves. So these are the terms, right? And so what we were typing in there were terms, and it recognizes all of these terms. We did examples of atoms, numbers, variables, and structures. Everybody, are we good? Okay. So now check this out. This is one that you're not going to be able to see. It's not going to be visible on the screen, but let's do this read x, write x. And now it's waiting for me to type something. Now you can't see this, but what I'm doing is, trust me, I'm going to press Control D. Now watch what happens. So what happened? End of file, right? So the Control D is, and by the way, what is this end of file that starts with lowercase e? What data type is that? That is an atom. Yeah, that's an atom. It's a special atom. Does everybody see how that works? So Control D is read as the atom end of file. Now, what about this? Instead of reading a variable, suppose we read ABC. ABC. Now, what do you suppose happens? Now it's waiting, just like before. It's waiting for. So now, what do you think of knowing how matching works? Well,
If you put an ABC, it'll match, but if you put anything
oh, that's excellent. If we put ABC period, then it matches. On the other hand, if we do this and we do DEF, then it doesn't match. So now do you see how we can test whether or not something is something that we want to compare it with by reading the thing that we want to compare it with, and then it will either succeed or fail.
So can you do read ABC and then capital X period?
Good question. Let's try it. Read ABC and do capital X period. And it does succeed because X is a variable. It doesn't give us that it matches, it gets instantiated to ABC, but it does succeed. That was a good question. That was a good demo. Okay, so here, what is our conclusion? Our conclusion is reading an atom succeeds if the input is the same atom. So let's go to there's a slide here that shows that is a summary of read X. Okay? So here's our summary of read X. The next term T is read and matched with X. If X is a variable, then X is instantiated to T. Okay, so we demoed that. If there is no match, the goal read X fails with no backtracking. And if control D is read from the keyboard or the end of file is reached in a file, then X is instantiated to the atom end of file. I actually summarized this. I don't think this text is in the book anywhere, but anyway, this summarizes what we just did. Okay, so that's read. Now, the next one that we want to look at is called put. Now, this is kind of strange. It's a little primitive, but let's check this out. If I say put, you might have a hard time. Does anybody know the magic number 65? Does that ring a bell at all with anybody, the value 65? Did anybody here have computer systems and looked at do you remember the ASCII chart? Do you remember any of those values? Look. Now watch this. So put 65 is uppercase A. Put 66, what do you suppose that's going to be? Yeah, that's uppercase B. Are you with me? Is everybody clear? And here, let's put 122. No one's memorized the ASCII chart? You don't know what number 122 is? Decimal. It's the lowercase z. Is everybody, are you with me? How about 48? You guys know 48? Oh, you guys don't know your ASCII chart. Oh, well. That's the character 0. Are you with me? Because the digits are characters on the ASCII number line, right? Character line. Okay, so then what is 49, obviously?
1.
Yes, that's the character 1. And what do you suppose, do you remember this one? 10? That's one of those non-printable characters. What do you suppose this is? Yeah, can you tell on the demo there that there's an extra space? It's the new line character. Are you with me?
What's the beep?
Oh, what was the beep? What was the bell? Yeah, I don't remember what that value was. If we knew the value, we could try it and we could see if it beeps. You're going to look it up real quick? So, 7?
Yeah, it's
Is it 7? Let's see if we can hear anything. Did you hear it? Here, let me. Okay, let's do it again. Are you ready for this? Yeah. So sure enough. All right. So we do remember some of that stuff. All right, so now what we're going to do is we're going to show an interactive program to prompt the user for the value to cube. And I'll tell you what let's do. Let's look at the code first and then we'll demo it. So check this out. Cube. Now this is cube 0, right? So what does that mean? What was the cube that we had before? This one up here was a 2-ary, but it knows we can have 2 different definitions of cube with different arity. Do you see how we don't have to name it anything different because it has a different arity? So this is a cube with arity 0. And what it does, here's what cube does. It does read X and then process X. So read makes it pause and wait for the input, and then once whatever we type in, then X is instantiated to that, and then it processes X. And then we process stop, and how do we process stop? And is this an atom or a variable, this stop?
I'm sorry. No.
it's an atom because it's lowercase, all right? So if we type stop, what will happen? It will match this, and then it will cut, and then end, and then once it, and the cut always does what? Always succeeds, but then it stops, and once it stops, then there's no backtracking. So it will succeed, and there won't be any backtracking, we'll be done. Are you with me? Otherwise, we process n if what? And then we do c is n times n times n, and then what do we do? Yeah, write c, and then put 10, go to the start of the next line. Are you with me? And then call cube again. The one array cube, which comes back up here and reads x and processes x. So here, let's do cube. Let's demo this. So we'll do cube, and now watch this. If we say 2 period, then what comes out? 8. And if we say 3 period, what comes out? 27. And if we say 4 period, what comes out? 64. And how do we get this thing to stop? We do what? STOP, and then boom. Now, does everybody see how that worked? Okay. Now, this next one, let's see if you can predict this. It's an interesting one. It's a second version of cube with arity 0, and I want to see if you can spot the error in here. This is an erroneous attempt to simplify cube, because what did our original cube do? It had read x, process x, and then it processed stop, and then it processed n. And you might get a little clever and say, why do we need all that extra stuff in there? Why don't I just say cube 2 if read stop, and then cube 2 read n, c is n times n, write output in cube 2. Can you see what the error in this? Anybody analyze this and try to figure out what the error is here? It is going to want to match whatever you put in to stop, and then if it doesn't match, so when we do 2, like if we want that to be our first one, 2 won't match stop, and then what's it going to do? And it's going to go into the second queue. Yeah. So it won't match here, but then it will do here. And what's the problem? It's doing another what? It's doing another read. So look. So the problem is if we say cube 2, and now if we do 2 period, whoa, it's waiting. So now if I do 3 period, well, it gives me the 27. And if I do 4 period, oh, that matched or failed with the stop. And then if I do 5 period, that one will work, right? So now I can stop it, but you see how, because we had these two reads, so that was just a little program to show that you have to be careful how you set up these interactive programs to do just, because see, look, the whole idea here is that you do the one read here at the beginning and then you process it so that we don't have that extraneous read in there. And you check to see if it stops on the next rule. You see what I mean? Okay. So this is our cube 2, which is erroneous. Now, this next atom is a special atom, NL. It looks like a 1, but it's an L. What do you suppose NL stands for? New line. So if we do, can you tell that there's an extra line there? If we do NL, 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 it becomes more obvious. See? So is everybody clear that NL, when NL is a special atom, that outputs a new line, okay? And so now what we're going to do is, watch this. I think we'll demo this one first. Let's do cube 3. Watch this. Now, this is much more user-friendly. Next item, please. Oh, okay, 2. Cube of 2 is 8. Next item, please. Oh, 3. Cube of 3 is 27. Next item, please. Stop, period. Okay, so this one's prompting for input. I'm glad Jonathan's not here. He would say this was boring. I should keep that in the I should keep that in the video for posterity. Okay, so let's take a look at cube 3. An interactive program to prompt the user for the values to cube. Cube 3 if. Okay, so now what's the first thing that we want to do? Well, is it read or I'm not sure. Is it read? I think we want to write next item, please. Are you with me? Okay, so write next item, please, and then read X, and then process 3X. Okay? Is everybody good? The third version of process. Okay? And now what? Process 3 stop, if, cut, and then end. And then process 3 end, if what? So now what will this be? C is n times n times n. But now what do we say? What happened down here? Yeah, so we say what? Write cube of, and then write n, and then write is, and then write c, and then do a what? New line, and then do cube 3. Yeah? Is all this pretty straightforward? I think it's fairly straightforward. Okay, now let's get a little fancy. Let's do write list. Let's do a little more processing. Write list L outputs each element of L on a separate line, one base case fact and one rule. Now before we look at the code here, let's do a little demo. Let's do write list, W-R-I-T-E, write list, and let's do A, B, 1, 2. So there's our list. And now watch what this does. Does everybody see what it does? It pulls it off, each element, and puts it on a separate line without any, just like that. Yeah? Okay? So how do you suppose we're going to do this? It's one base case fact and one rule. Well, what's the base case fact? The base case fact is pretty straightforward. If it's empty, just do what? Yeah. Well, that's just it. We're done. Okay? Otherwise, oh, and by the way, if it's empty, this will succeed and it will go to this and this will fail and then it will quit. Now, is everybody with me on that? Okay? So if it's empty, this will succeed, then it will go to this, and nothing will happen, and it will go to this, and then this one will fail, and then it'll stop. Okay? So write list XL if what? Yes. And then new line. Okay, on the next line. And then write list L. Huh? Pretty simple. Is everybody clear with that? Okay. Now, check this out. Let's see how tab works. Let's do write A, write lowercase a, and then write lowercase b. Now if we do this, what's going to come out? If we do this, what's going to come out? Yeah, A, B, and they're right next to each other. I mean, visually it looks like they're kind of together, even though they are separate atoms. So we can separate them. We can do write A, and then before we do write B, we can say tab 1. And then write B. Now if we do this, watch what happens. Are you with me on that? So that puts that little space in between, and if we do this 2, then 2 spaces. They say tab, it comes out as a space, however many spaces. Does everybody see how tab works? Are we good? Okay, so now now let's go to our next one, which is write list to LL. LL is a list of lists. It outputs the elements of each list of LL on a separate line. So let's see what it does here before we look at the code. Let's do write list 2, but now look at what we're going to write list 2 of. We're going to have a list of A, B, C. Oh, wait. We're going to have a list of the list ABC, and then the list DEF. And now that is a list of lists. So that LL is a list of lists. Now watch what this is going to do. Okay, so now that we saw this demo, A, B, C, D, E, F, let's see if we can write the code. So this is write list 2. So how do we, what's the base case? The empty list. So with the empty list, we don't have to write anything. Yeah? Otherwise, we write list now. This is interesting notation. So L is the first element of the list, but it is a list. And then after the vertical bar is LL, which is a list of lists. Are you with me? So L is going to be instantiated to the first element of the list of lists, which is a list. And so what's the first? So then what do we do? Yeah, what we'll do is we'll have a predicate called doLine. We're not going to use our previous write list. Oh, that's interesting. I wonder if we could have done our previous.
Because it does it in different lines.
Yeah. So we're going to call doLine is in essence going to be what we did before, right? So we'll doLine L and then write N1 and then do write list to LL. Is everybody clear with that? And now what does doLine do? What's the base case for doLine? Yeah, it's the empty list. So we'll doLine the empty list. We don't do anything. Otherwise, we doLine XL. We write X. We tab 1, and then we doLine L. Is that straightforward? Okay. All right. And here's another one, just to show you something slightly more interesting. Bars. L is a list of integers. It prints a row of n stars for each number n in L, and it ignores any negative values. So to demo that, let's do bars. Now watch this. Let's do bars, and we're going to have a list of numbers. 5, 2, negative 3, 4. 5, 2, negative 3, 4. Okay. And are you ready for this? Drum roll. There's a little bar chart. This is a favorite example. We did this example in assembly language. Do you remember? This makes a nice little illustration of loops.
So the negative 3 just doesn't print anything?
Correct. The specification here is up here. Ignore any negative values. Yeah? Are we good? So what's obviously the base case? Yeah, if the list itself is empty, then we don't print any bars. Otherwise, we match it with, otherwise we do bars what? Otherwise, we do bars what? It's the same pattern. What's the pattern here? Yeah, NL, where N is the first number and then L is the rest of the list of numbers. Are you with me? And now what do we do?
We need to evaluate what n, if n is less than equal to 0.
Correct. And we're going to do that in another predicate called stars. So we'll do stars n, and then we'll do a new line, and then we'll do bars L. Yeah? And now what will stars n do? Stars n if what? So now comes that test that you were talking about, right? So what happens? If n is greater than 0, we have work to do. And what do we do if n is greater than 0?
Print out the star. You could write star.
Yes.
And then initialize n1 or something.
Yeah, and then have another variable n1.
N minus.
which is, and you can say is
Is
n-1, and then do stars of that one. Yeah? So write star n1 is n-1, and then do stars n1. Oh, and then do we have another one, another stars n?
Oh, yeah, n is less than 0.
which is the new line.
Which is new line.
Oh, right, if it's less than or equal to 0. Oh,
Why don't we do
yeah, why,
an L, right?
Oh, because the new line is in bars.
Oh,
So it
oh, that's right, the new line is up here.
does a new line. And
Yeah.
so it just, yeah, it checks and then it does new line. And that's
Yeah, it checks and it succeeds, and then and then for the next solution it'll come back up to here. Okay? Are we good? Okay, so that's bars. Now, this next one shows how Prolog communicates, gets input from a file. All right? And what we have here is the thing of it is that the default input is the keyboard, but there is a way to get information from a file by redirecting. Okay, so let's go to the slide and see how Prolog communicates with files. So what happens is the default is to have the user terminal be have the stream come from the user terminal. So like when you type a term on the terminal, then that's the input, and then whenever the Prolog replies, it sends that stream to the terminal. So both the input and the output is the terminal, right? But you can have input streams come from files, and you can have output streams go to files, right? And so this figure 6.5 shows that the user terminal can be thought of as both an input file, an input stream, and as an output stream. But basically, it's the same thing can happen. It works the same way, even by processing information from files. Okay? So now, to show how this works, let's do this. Let's come back up here to our top panel, and let's quit more. And there is a file up here. Do you see it? It's called dog data, right here. Yeah? And let's take a look at the content of dog data. Let's more dog data. Now look at what dog data has in it. My period, dog period, has period, 57 period, fleas period. And each one of these is a term that ends with a period. Are you with me? And so that's dog data. Now there's another one here that's interesting that's called GCD. Actually, we used the GCD one before, didn't we? Here, it's up here, GCD. Let's more that. Do you remember that? GCD.pl. So this is that GCD. Remember didn't we do this the other day? The x times x times x. Or the GCD of x and x is x. If it's the same, then that's the GCD of x. And then GCD of x, y, d. D is the GCD of x and y. If x is less than y, y1 is y minus x, GCD y1 d, and then, remember that? We did the logic of that. Well, now it's in a file called GCD. And now, watch this. Show file. Show file in. Print the terms in the current stream with consecutive numbers starting with n. And here's what we're going to demo. We are going to demo see and seen. All right? Now, the way you switch between having the input come from the terminal and having the input come from a file is you tell Prolog to see the file. Are you with me? And then when it sees that file, then everything, then everything, all inputs then will be taken from that file instead of taking it from the terminal. So what that does is that disables the terminal. If you do C and you don't do scene on the same line, then you've lost control of the keyboard. Are you with me on this? So we have to do this all on the same line. So look, let's copy this whole thing. And what are we going to do? We're going to say C dog data. So that means the input from show file, then when it executes show file, the input from show file is going to come from dog data. And then after that show file finishes executing, then we'll do scene and we will return to the keyboard input. Is everybody with me on this? So let's copy this and let's come down here. Oh, true. There. All right, let's copy that and let's put it here. Now watch this. Are you ready for this? 0, my, 1, dog, 2, has, 3, 57, 4, fleas. Does everybody see what scene does? And how we temporarily redirected the input to come from a file, dog data. Okay? So let's take a look at how show file does its thing. Oh, by the way, maybe before we do that, let's demo this one more. Let's see GCDPL and do show file and then do scene. So let's copy that. Come down here and watch this. Now, does that look familiar? It took each one of those as a term. Each rule, are you with me? It took each rule and then it did the terms. It did the terms inside the rules, right? But it recognizes the prolog syntax. Okay, so I don't know if you remember. If you remember, there were three. Actually, here it is. There were three rules. Oh well, I can't. Yeah. There were three rules there. Okay, so let's take a look at show file n. So read term. Now where's it going to read it from? It's going to read it from the file because we said C dog underscore data. So read term, and then show term. We're going to have to write show term n, and then how do we get to the end of file? So does everybody see? We read term, and then show is the next predicate that we're going to write to process the term that we read. Are you with me? And then if that matches the end of file, which is that atom, remember that that term gets instantiated to if it's at the end of the file. If that's true, then it doesn't matter. It doesn't matter what n is. By the way, what's the arity of show? 2. Okay, so it doesn't matter what this number is. If that matches, then we cut and then stop. All right? And if it doesn't match, then we show term n. Okay? And by the way, what is the value of n? It was initially instantiated to 0 up here.
Does that mean it keeps going up?
Yes, it's going to keep going up. Notice that we instantiated it with 0 here, so that n has a value now. It is 0. And so what we do is we'll calculate, we will write n, and then we'll tab 2, and then we'll write term, and then we'll do n1, and then we'll do n1 as n plus 1, and then we'll show file with the incremented value of n. Are we good with this, you guys? Is this? All right. So that's how you do see and scene. And just one more concept here, and this is the concept of get. Actually, get 0. Get 0 is built in. This 0 is the name of the functor that's built in. When you say get 0, C is the next single character from the input stream. So check this out. If we say get 0, capital X. Now, didn't we do get before? Or no, we did put. Yeah, we did put. So this is get 0. So if we say get 0x, now what's going to happen is I don't press period. If I just do A, then what does X get? The what? The ASCII number of A. Are you with me? So the way it does character processing, string processing, is it does it with these ASCII characters. All right?
I'm a little confused though. What is the purpose of get 0? Like,
It's to be able to get a character and have it have the ASCII value of that character. Because see, look, if we do get here, if we do get 0 of X, and then if we do put, because what was put, how did put work? Right, so you see this is the opposite of this. So if we say get 0x put, and now if we do A, it's going to do get the A, and then it's going to put it out, okay, and matched with 97. You see, it's the opposite of what get 0 is the opposite of what put does. Are you with me on this? Okay. All right. So now, but now here's the thing: space is a character, right? So if we say get 0, and then X. And here, it's waiting for us to type something. If I type space and then return, notice that 32 is the space character. Are you with me? Okay, so now the difference between get 0 and just get is if you use get, now watch, if we say get X, or here, let's do that again. If we say get 0x, and here if we type space, and then like A, B, C, what's it going to get? Or sorry, A, B, C, what's it going to get? It's still going to get that 32, that space. Do you see what I mean? Because I had a space, it's the first space. So the difference between get and get 0 is if we say get X, and now,
get 0.
No, I wanted get. Why? Oh, I know why. Haha. Yeah, this was interesting. It was left over with the ABC. Yeah. See, look, if I do get X like this, and now if I do all these spaces, and then I do A, then it actually gets the A. But what happened before with this, actually this is an interesting, this is a relevant error message, because what happened was when we did get 0x, it got this, but the ABC was still in the input stream. Do you see what I mean? The ABC was still in the input stream. That's why we got this uncoded, this unsought.
You could press semicolon? Is that what you're saying?
No, because it came back with the prompt. The semicolon just would have been in that other string. Okay? All right. Well, anyway. So that's it. Now, so did you have an assignment tonight? Was your last assignment due tonight? Okay, do you want some extra time for that? Or at any rate, we will, okay, would you like, okay, if you'd like some extra time for that, maybe we can talk about any questions that you have for that in class tomorrow, and then we can review for the exam. And when's the exam? The exam's on Thursday? Yeah, I think it's Thursday. Oh, do you realize what that means? If the exam is on Thursday and we meet on Friday, that means we start a new paradigm. on Friday. And the paradigm is going to be the concurrency, the concurrent paradigm. Okay, so see you tomorrow.